Hello there, and welcome to Just About Earth, where curiosity gets cozy and science takes the scenic route to slumber. Tonight we begin with a thought that might sound heavy at first, but I promise it will unfold gently, like the slow turning of pages in a book that's been sitting on a shelf for billions of years. What if humanity isn't the grand climax of life on this planet? What if we are not the pinnacle we often believe ourselves to be, but simply one temporary chapter in Earth's 4.5 billion year story? It's a question that lingers in the background of history, like a quiet echo, waiting for us to notice it. And when we do, it can feel unsettling. But it can also feel strangely comforting, because it places us in the context of something so much larger than our individual lives, or even our species. Before we move further, let me ask you something personal. Where are you listening from tonight? Maybe you're curled up in bed, earbuds in, winding down after a long day. Maybe you've just pressed play because sleep feels a little far away and you'd like something soft and steady to keep you company. Maybe you're not even listening at night, but in the middle of the afternoon or during a morning commute. Whatever time it happens to be, and wherever you happen to be, here we are, sharing this same moment together, across time zones and distances, joined by nothing more than a voice and a question. If you find comfort in this kind of exploration, if the pace feels soothing or the curiosity feels like the right kind of gentle company, I'd be truly grateful if you gave this video a like, or maybe subscribed. It helps this small corner of calm reach others who might also need a space like this, a chance to pause, breathe, and wander through ideas that are both vast and reassuring. Now let's ease into the story itself. Earth's history stretches back about 4.5 billion years. If you try to picture that span, it's overwhelming. The human brain is not well equipped for numbers that large. We can hold on to the idea of 1,000, maybe 1,000,000, but billions begin to blur into something that feels more like abstraction than reality. Yet that is the age of this world beneath our feet. And for almost all of that time, we weren't here. No humans, no hominids, not even mammals for most of it. When you look at the timeline of Earth, our presence is so brief that it barely registers. A thin line at the very end of a very long scroll. Imagine condensing Earth's entire history into a single day. The planet forms at midnight, a ball of molten rock cooling under a violent sky. The first simple life appears around 4 a.m., tiny microbes drifting in ancient oceans. Multicellular life doesn't arrive until evening. Dinosaurs don't step onto the stage until late at night. Humans, in this 24-hour analogy, appear only in the last few seconds before the next midnight. Civilizations, cities, everything we call history would be nothing more than a single blink. And yet, we often speak as though the Earth was waiting for us, as if the forests grew, the rivers carved valleys, the continents shifted, all in preparation for our arrival. But the truth is more humbling. The Earth has been through countless transformations, extinctions and rebirths without us. It will continue to do so long after we're gone. It doesn't need us to complete its story. We're a part of it, yes, but only a part. One of many phases, not the grand conclusion. Think about the species that came before us. Trilobites crawling across seabeds 500 million years ago, their segmented bodies leaving fossils that still shimmer faintly in stone. Great forests rising in the Carboniferous period, their trees towering over a world where insects grew to the size of birds. Reptiles dominating land, sea and sky during the age of the dinosaurs. Each of these groups had their time, their dominance, their moment to define the planet, and then, eventually, they passed away. Sometimes slowly, sometimes abruptly, but always inevitably. Extinction is not rare, it is the rule. Permanence belongs to stone and ocean, not to species. And so we come to ourselves, humans with our languages, our tools, our art, our technology. We often talk about ourselves as though we've reached the pinnacle of evolution, as though intelligence were the final goal of life, and we were the result it was striving toward all along. But what if that isn't true? What if intelligence, at least the kind we have, is just one strategy among many, one experiment in the vast laboratory of evolution. Maybe it will endure for a time, maybe it won't. Perhaps another form of life, unimaginably different from us, will take the stage millions of years from now. To them, we might look like a fascinating but temporary experiment, just as we look at the dinosaurs or the ammonites today. When you think about it this way, the pressure lifts a little. Because if we are temporary, if we are not the climax but just a chapter, then the weight of having to finish the story is not on us. Our role is not to be permanent, but to be here now, to exist within our moment, to leave traces where we can, and to accept that those traces will fade in time. The earth has patience far greater than ours. Mountains rise and erode, oceans open and close, climates shift, species appear and vanish. We are not the exception to that rhythm. We are a part of it. Even the things we think of as lasting monuments, skyscrapers, satellites, great works of art, even the global internet, are fragile in the long view. Given enough time, stone crumbles, metal rusts, orbits decay, servers fail. The fossils of trilobites survived longer than most of our achievements will. The Earth remembers in stone and sediment, not in digital archives. Our traces may endure for a while, but they too will eventually be overwritten. And maybe that's not something to mourn. Maybe there's comfort in knowing the story continues without us. After all, every species before us has given way to something else, and every extinction has opened space for something new. The dinosaurs vanish and mammals rise. Giant ferns retreat and flowering plants spread. Microbes thrive in the shadows of mass extinctions, waiting patiently for their chance to shape the world again. If humans disappear one day, life will not stop. The forests will return. The oceans will refill with creatures. Perhaps even intelligence will rise again, in a form we can't picture. Maybe birds or cephalopods or something entirely new will carry the torch of awareness into the far future. And here's the strange thing. Even if that happens, even if humans vanish entirely, our time here will still have mattered. Not because it lasted forever, but because it was part of the flow. We shaped the earth, left our marks in its layers, and lived our brief span in its great story. Being temporary doesn't mean being meaningless. It means being woven into a fabric so vast that no single thread needs to hold it all together. So tonight, as we begin this exploration, think of the question not as something grim, but as something expansive. What if humans are not the pinnacle, but a phase? What if our place in the story is not the end, but just one of many moments, unfolding in a timeline too big to fit inside us? If we want to understand why humanity might only be one temporary chapter in the Earth's vast history, we have to step back, far back, to a time when there was no hint of us at all. No forests, no animals, not even a blade of grass. Picture the Earth in its first beginnings, 4.5 billion years ago. It wasn't the blue and green planet we know today, but a glowing sphere of molten rock, hammered by asteroids, simmering under a young sun that was weaker than it is now but still harsh. The atmosphere wasn't breathable, the oceans hadn't yet formed, and the idea of life was nowhere in sight. This was a place defined by fire and stone, where the surface hardened only to be torn open again by constant bombardments from space. We call this time the Hadean Aeon, named after Hades, the underworld of Greek mythology, because it really did resemble something like hell. Volcanoes erupted endlessly, continents didn't exist, and the sky was filled with thick toxic gases. Yet out of this chaos came the first steps toward the world we know. Slowly the bombardment eased, the surface cooled, and water began to gather. Comets and asteroids brought ice, and steam from volcanic eruptions condensed into rain. Over millions of years, those rains filled the basins of the cooling planet, and the first oceans appeared. Imagine that moment, if you can. the sound of rain falling for centuries, drop after drop, until it became seas stretching farther than the eye could see. These oceans were silent at first. No fish swam in them, no plants grew along their shores. They were chemical laboratories, mixing minerals and molecules, stirred by tides and heated by vents from the Earth's crust. In those conditions, something extraordinary happened. We don't know the exact recipe, and scientists still debate the details, but somewhere in those silent waters, life began. The earliest microbes, so small they were invisible to the eye, emerged and found a way to replicate. They had no brains, no nervous systems, nothing resembling thought, yet they carried within them the spark of something entirely new, the ability to grow, to adapt, to evolve. And this is where Earth's story truly begins, because without those first microbes, nothing else would follow. It's humbling to realize that the creatures we often overlook today, bacteria and single-celled organisms, were the original rulers of the planet. They shaped the atmosphere, they invented photosynthesis, they transformed oceans full of dissolved iron into clearer waters. In fact, for most of Earth's history, life was nothing but microbes. Not just for a brief span, but for billions of years. Think about that. The Earth is 4.5 billion years old, and for almost 3 billion of those years, life never got beyond single cells. During that time, the surface of the planet was anything but still. Continents were beginning to form, but they looked nothing like the ones we know. They drifted slowly, colliding, breaking apart, creating mountain ranges that rose and eroded again long before our familiar continents took shape. The sky changed too. At first, Earth's atmosphere had no oxygen, only carbon dioxide, methane and nitrogen. If you were to step into that world, you wouldn't survive more than a few seconds. But then, tiny cyanobacteria began releasing oxygen as a byproduct of photosynthesis. At first, that oxygen reacted with iron in the oceans, staining rocks with vivid red layers we can still see today. But eventually, it built up in the atmosphere, creating what scientists call the Great Oxidation Event. It was one of the most dramatic shifts in Earth's history, turning the air toxic for many forms of life that couldn't handle oxygen, but paving the way for more complex organisms to evolve. If you were to stand on Earth during this early time, what would you see? The landscapes would be harsh. Volcanic islands scattered across vast oceans, barren rocks with no plants, skies tinted with strange colours from volcanic gases, lightning flashing through heavy clouds, the smell of sulphur and metal in the air. And beneath those waves, hidden from sight, the first cells multiplying quietly, changing the chemical balance of the world one tiny step at a time. There were no trees, no animals, no birdsong, but the story of life was already underway. It's easy to overlook this part of the story because it lacks the drama of dinosaurs or the familiarity of mammals. Microbes don't leave towering skeletons in museums. They don't capture the imagination of children drawing pictures of ancient worlds. But in many ways they are the most important characters in Earth's history. Without them, the atmosphere would never have shifted to something breathable. Without them, the stage for more complex life would never have been set. Every breath you take is thanks to countless generations of microscopic ancestors who slowly filled the air with oxygen. It's worth remembering this when we ask whether humans are the pinnacle of life. Because if dominance is measured in time, then microbes still win by a landslide. They've been here since the beginning, and they're still here now. They outnumber us. They outweigh us. They survive in environments we can't even approach, from boiling hot springs to radioactive waste to the crushing depths of the ocean. We often imagine intelligence as the ultimate achievement, but if survival is the measure, then the crown doesn't belong to us at all. It belongs to the microbes, who have thrived through every catastrophe the Earth has thrown their way. When we look back at this earliest chapter of Earth's history, it becomes clear how fragile our place in it really is. Life didn't begin with us, and it certainly doesn't depend on us. The Earth's first inhabitants were not humans or even animals. but tiny cells that no one would notice unless they looked through a microscope. And yet, those tiny cells shaped the future in ways beyond their own comprehension. They didn't know they were laying the groundwork for forests or insects or mammals or people. They were just surviving, adapting, dividing, carrying on. And perhaps that's a lesson we can take too. Survival isn't about being the most dramatic or the most intelligent. It's about finding a way to fit into the rhythms of the planet, however harsh they may be. The Earth doesn't guarantee permanence to any of its inhabitants. It didn't to trilobites, or to dinosaurs, or to the great forests of the past. It certainly won't to us, but it does reward adaptability, patience, and resilience. Microbes have those qualities in abundance, which is why they are still here, still thriving, still waiting, long after countless other species have vanished. As the Earth moved from these fiery beginnings into a world with oceans and the first stirrings of breathable air, the stage was being set for the next act in its story. But those acts were still far away. For billions of years, the planet remained quiet by our standards. No sounds of animals, no rustle of leaves, no wings in the sky. Just the wind, the waves, the crackle of volcanoes, and the microscopic labour of cells multiplying in the dark. It was a patient beginning, slow and deliberate, and it reminds us that the Earth's timescale is not ours. What feels eternal to us is fleeting to the planet, and what feels unbearably long to us is only a moment in its memory. If you were to step back into the earliest eras of Earth's history, long after the firestorms of its formation had quieted and oceans had spread across its surface, you wouldn't find towering dinosaurs, lush forests, or even the simplest plants. You'd find a world ruled almost entirely by things too small to see. It's strange to imagine because when we picture life, we picture it in forms we can touch and recognize. Yet for most of Earth's history, the true rulers were microbes. They didn't just survive, they thrived, and in their own way they reshaped the planet more dramatically than any creature that came after. The timeline alone is staggering. Microbes appeared over 3.5 billion years ago. To put that into perspective, if you condense the entire history of Earth into a single calendar year, microbes would arrive in mid-February, while humans wouldn't show up until the very last few minutes of December 31st. That means these tiny organisms had the planet almost entirely to themselves for 10 or 20 times longer than any recognizable animals. It was their world, and everything that came later owes its existence to them. These organisms weren't identical. Some were bacteria, some were archaea, two domains of life that still dominate today. They developed astonishing ways to make a living in environments that to us would seem impossible. Some microbes drew energy from minerals dissolved in seawater, others from chemical reactions near volcanic vents, still others from sunlight once the trick of photosynthesis evolved. The remarkable thing about microbes is their flexibility. They don't need oxygen, they don't need mild temperatures, they don't need what we consider habitable conditions. As long as there's a source of energy and the right chemistry, some microbe will find a way. The greatest transformation they brought about was the oxygenation of the atmosphere. For the first billion years of their reign, Earth's skies contained almost no oxygen. Then a group of microbes called cyanobacteria discovered how to use sunlight to split water molecules and release oxygen as a byproduct. This might sound minor, but it completely changed the trajectory of the planet. Oxygen, at first, was toxic to most other organisms. It triggered one of the earliest mass extinctions, wiping out countless species that had thrived in an oxygen-free world. But for those that could adapt, oxygen was a game changer. It allowed for more efficient energy use, setting the stage for larger, more complex cells, and eventually multicellular organisms. Scientists sometimes call this event the Great Oxidation, and it's one of the most dramatic examples of life altering its own planet. Imagine the irony. The tiniest organisms in existence, completely invisible to the naked eye, reshaped the sky itself. And they didn't know it, of course. Microbes aren't conscious in the way we are. They weren't planning for the future. They were just surviving, replicating, competing. Yet in doing so, they accidentally wrote the script for everything that followed. Forests, animals, people, technology. None of it would exist without the oxygen those early cells released. And their story isn't just ancient history. Microbes are still with us, still dominating in ways we rarely notice. In fact, they vastly outnumber us. By some estimates, the number of microbes on Earth is in the nonillions. That's a 1 followed by 30 zeros. They inhabit every environment you can imagine. Boiling hot springs, deep sea vents where pressures would crush us instantly, frozen glaciers, acidic lakes, radioactive waste, even inside our own bodies. Right now, trillions of microbes are living in your gut, breaking down food, regulating your immune system, even influencing your mood. In subtle ways, scientists are still uncovering. It's humbling to realize that even today, in the so-called age of humanity, we are utterly dependent on microbes. Without them, we wouldn't digest food, plants wouldn't absorb nutrients from soil, ecosystems would collapse. We imagine ourselves as the dominant force on the planet, but the truth is that microbes still run the show behind the scenes. They are the foundation upon which every ecosystem is built. If we measure success in terms of longevity, microbes have already won. Species like us may come and go, but bacteria and archaea have been thriving for billions of years. They've survived asteroid impacts, ice ages, supervolcanoes, and the shifting of continents. They outlive the trilobites, the ammonites, the dinosaurs, and they'll almost certainly outlive us. There's a quiet lesson in that. Survival isn't about size or intelligence, it's about adaptability. Microbes have it in abundance, which is why they're still here. There's another fascinating part of their reign, one that connects directly to our own existence. Complex life, meaning anything with cells that have nuclei and organelles, only appeared because of microbes. One of the leading theories in biology is that complex cells originated when one microbe engulfed another, and instead of digesting it, they formed a partnership. The engulfed cell became what we now know as the mitochondrion, the powerhouse of complex cells. This event, called endosymbiosis, was the spark that eventually led to multicellular organisms like plants, animals, and us. In other words, we are literally built on microbial partnerships. Every breath you take, every heartbeat, every thought in your brain depends on tiny organelles that were once free-living microbes. When you step back and think about this, the idea that humans are the pinnacle of life feels shaky. Microbes shaped the earth before us. They continue to sustain it now, and they'll remain long after we're gone. Our intelligence may be impressive, but their resilience is unmatched. They don't need cities, or technology, or art to secure their survival. Their strategies are simpler, but far more enduring. Consider this too. Most of Earth's living biomass is microbial. When we walk through a forest, we notice the towering trees, the bird song, the scurrying animals. But beneath the soil, invisible to our eyes, lies a vast web of microbial life that outnumbers and outweighs all the animals combined. The forest above ground is only possible because of the unseen world below. It's a reminder that what we notice isn't always what matters most. If you zoomed out far enough, the age of microbes would dominate the timeline of life far more than ours ever will. Our age, if we get one at all, will likely be brief, a thin line on the fossil record. Microbes will have pages upon pages, entire volumes of Earth's story written in their favour. And maybe that's as it should be. They were here first. They've proven they can survive nearly anything. They are the invisible monarchs of this world, even if we rarely give them credit. As we think about whether humanity is temporary, it helps to remember that we live in a microbial world. We are guests here, and though we've made dramatic changes, the hosts are still the same tiny organisms that began their rule billions of years ago. They don't demand recognition. They don't even know they're in charge, but they are. And when our species eventually fades, As all species do, microbes will continue their quiet work. They will decompose our cities, recycle our remains, and carry on as they always have. Life on Earth does not depend on us, but it will always depend on them. They are the ancient foundation, the ever-present rulers, and the inevitable future. After billions of years where microbes ruled the planet almost entirely unseen, the Earth began to change in ways that were visible, dramatic, and world-shaping. Oxygen was already creeping into the atmosphere thanks to cyanobacteria, but now it began to accumulate in larger amounts, and that changed everything. Oxygen made it possible for bigger, more complex organisms to appear. For the first time, life wasn't confined to the oceans alone. The stage was being set for a new era, one where the land itself would come alive. Imagine standing on the shore of a world before plants had spread across it. The land would look barren, mostly grey and brown, with rocky coastlines, dusty plains, and little vegetation beyond patches of algae or microbial mats. There were no forests, no grass, no flowers, nothing green at all. The air would feel strange to us, not yet fully rich in oxygen, and the climate would shift wildly between extremes. This was a planet waiting to breathe in a new way. Then, slowly, plants began to spread. It started with simple moss-like organisms hugging the ground, small and low to the soil. These pioneers were the first to anchor themselves outside the ocean, drawing nutrients directly from rock and thin soils. Over millions of years, plants developed roots, stems, and leaves, and the landscapes of Earth were transformed. Suddenly what had been bare stone became green. Hillsides were cloaked with vegetation. Coastlines sprouted the first forests. And as plants grew larger, taller, and more numerous, they began to pump oxygen into the atmosphere at levels higher than ever before. This was one of the great turning points in Earth's story. Oxygen wasn't just a gas. It was a force that rewrote the possibilities for life. With more oxygen available, animals could grow larger and more active. Ecosystems could support new complexity. Insects flourished, some of them growing to enormous sizes in oxygen-rich air. Amphibians crept out of the water, followed eventually by reptiles. Every breath they took was made possible by the silent work of plants. Forests in particular changed everything. A single tree is not just a structure of wood and leaves. It is a machine for photosynthesis, drawing carbon dioxide from the air, releasing oxygen, and creating sugars that feed countless other organisms. Multiply that by millions of trees in a forest, and you have a planetary-scale system that reshaped the chemistry of the atmosphere and provided habitats for an explosion of biodiversity. The first great forests appeared during the Devonian and Carboniferous periods, more than 300 million years ago. These weren't the forests we know today with familiar oaks and pines. They were made of towering ferns, giant horsetails, and strange tree-like plants that don't exist anymore. Their trunks rose high above swampy ground, their roots dug deep into soils, and their leaves formed dense canopies that changed the way sunlight reached the Earth's surface. Beneath them, insects buzzed, amphibians hunted, and the first reptiles crept through tangled undergrowth. Those forests also did something else remarkable. They locked away vast amounts of carbon. When plants died, much of their material was buried in swamps and sediments where it didn't immediately decompose. Over millions of years, that buried plant matter turned into coal, oil, and natural gas, the fossil fuels we use today. So when we burn coal in power plants, we are literally tapping into the energy of forests that grew hundreds of millions of years ago. It's a strange connection between our modern civilization and those ancient landscapes. But perhaps the most lasting legacy of these forests was the transformation of the atmosphere. Oxygen levels rose to unprecedented heights. During parts of the Carboniferous period, oxygen may have made up over 30% of the atmosphere, compared to 21% today. This surplus of oxygen allowed some insects to grow to enormous proportions. Dragonflies with wingspans the size of hawks, millipedes longer than a human. It must have been a surreal world, both familiar and alien. And with this new abundance came new complexity. Ecosystems grew more layered and interconnected. Plants supported herbivores, herbivores fed carnivores, and decomposers recycled the waste back into the soil. It was the beginning of the intricate web of life we recognize today. The land was no longer silent and bare. It buzzed, croaked, rustled, and echoed with the sounds of life. The planet had learned to breathe through forests, and in doing so it set the stage for everything that followed. If you zoom out and think about this moment in Earth's history, it's another reminder of how temporary our own age might be. Plants and forests reshaped the entire world, but the first great forest did not last forever. Many of the dominant tree-like plants of the Carboniferous eventually disappeared, replaced by new lineages, new ecosystems, new rhythms. The forest as an idea endured, but the specific players changed. Extinction swept through again and again, as it always does, clearing space for new forms of life. And when you trace that pattern forward to today, you can see that our forests too are temporary. The rainforests, the boreal forests, the temperate woodlands we know now, all of them are just another phase in a longer story. They feel ancient to us, but compared to the age of the planet, they are fleeting. If climate shifts, or if ecosystems collapse, or if human activity continues to cut them down at the pace it does today, these forests will also change, disappear, or transform. Life will go on, but it won't look the same. Oxygen itself, the thing we rely on with every breath, is not guaranteed in fixed amounts forever. It's the product of balance. Photosynthesis on one side, respiration and decay on the other. If that balance shifts, so does the atmosphere. Earth has gone through times when oxygen levels were lower, times when they were higher, and times when they nearly collapsed. What feels permanent to us, the air we breathe, is actually the result of countless living processes working together, most of them invisible and uncelebrated. This perspective makes it easier to see how humans fit into the bigger picture. We often talk about how we've changed the planet, and it's true, but plants changed it first, on a scale we can barely imagine. Microbes made the first atmosphere, and plants made the second. They set the stage for animals, including us. We like to think we're unique in our impact, but we're really just the latest in a long series of organisms that altered the planet to suit their needs. The difference is that microbes and plants didn't know they were changing the world, while we do. Yet knowledge doesn't make us permanent. Just as those first forests eventually vanished, so might ours. Just as oxygen levels rose and fell over the ages, so might they again. Everything is temporary in the grand timeline, even the very air we take for granted. And so, when we ask whether humanity is the pinnacle of life or just a phase, the forests give us an answer in their own way. They remind us that dominance comes and goes, that no system lasts forever, and that even the most powerful transformations eventually yield to new ones. The planet is always learning to breathe in new ways, always rewriting its own rhythms. When we think about the history of life on Earth, it's easy to imagine a steady march of progress. First microbes, then plants, then animals, then eventually us, as if the story were a smooth line moving upward. But the truth is far less linear. Earth's story has been interrupted again and again by extinctions. Entire worlds of creatures have risen, flourished, and then disappeared, often leaving only fossils behind. Extinction is not rare. It is normal. It's the punctuation that marks the end of one sentence and the beginning of another. The first time you really sit with that idea, it can be sobering. More than 99% of all species that have ever lived are gone. Let that number sink in. Nearly everything that has ever existed on this planet has vanished. Every trilobite that scuttled along ancient sea floors, every giant dragonfly that once soared in oxygen-rich skies. every towering tree of the Carboniferous forests, every dinosaur that thundered across the land, gone. Extinction isn't the exception to life, it's the rule. And yet, extinction doesn't mean failure, it means change. Sometimes it comes slowly, as climates shift or ecosystems transform. Sometimes it comes suddenly, as asteroids strike or volcanoes erupt. Either way, extinction clears space for something new. Life is constantly rewriting itself, erasing chapters and starting fresh with new ones. Take the trilobites, for example. These armoured arthropods appeared more than 500 million years ago at the dawn of complex animal life. For nearly 300 million years, they thrived in oceans all over the world. They were enormously successful, with thousands of species adapted to every niche imaginable. And then, during a mass extinction event at the end of the Permian period, they were wiped out completely. No trilobite survived, but while they disappeared, other groups, like early crustaceans and insects, carried on, filling the spaces they left behind. The Permian extinction itself was one of the most dramatic turning points in Earth's history. It's often called the Great Dying. Around 250 million years ago, something catastrophic happened. Massive volcanic eruptions in what is now Siberia released vast amounts of carbon dioxide and other gases, triggering runaway climate change. Oceans turned acidic, temperatures spiked, ecosystems collapsed. It's estimated that more than 90% of all marine species and 70% of land species went extinct. It was the closest life has ever come to ending entirely, and yet it didn't. Out of that devastation came new beginnings. The extinction that ended the Permian period set the stage for the rise of the dinosaurs. Without the Great Dying, reptiles might never have become the dominant form of life on land. Extinction, in this sense, was a rewrite. It closed one world but opened another. And of course, the dinosaurs themselves eventually met a similar fate. For more than 150 million years, they ruled the planet. They diversified into countless forms, from towering sauropods to swift raptors to armored giants. Then, around 66 million years ago, a large asteroid struck what is now the Yucatan Peninsula. The impact released unimaginable amounts of energy, triggering wildfires, tsunamis, and a nuclear winter effect that blocked sunlight for months or years. Plants withered, food chains collapsed, and the non-avian dinosaurs disappeared. But again, extinction wasn't the end of life. It was the turning of a page. Mammals, which had lived in the shadows of dinosaurs for tens of millions of years, suddenly had room to flourish. They diversified, adapted, and eventually gave rise to us. When you think about it this way, extinction is the engine of novelty. It's brutal, but it makes room for new experiments. Without mass extinctions, the history of life would look very different. Humans might not exist at all, but extinction doesn't always arrive in catastrophic bursts. Sometimes it creeps in quietly, almost unnoticed, as conditions shift over long timescales. A species might decline because a new competitor arrives, or because its environment gradually changes. Think of the mammoths and saber-toothed cats of the last ice age. They weren't wiped out by a single asteroid or volcano. They faded slowly, through a mix of climate shifts and human hunting pressure. For thousands of years they coexisted with early humans, and then one day they were gone. In this sense, extinction is a constant background hum in the story of life. Species are always appearing and disappearing, even without dramatic disasters. It's estimated that the average lifespan of a species is about 1 to 10 million years. That means extinction is baked into the very fabric of evolution. To exist is to be temporary. This brings us back to the question of where humans fit into this story. If 99% of species have already vanished, why should we be different? The Earth doesn't promise permanence to anyone. We like to think of ourselves as exceptional, but we're bound by the same rules as trilobites, ammonites, mammoths, and dinosaurs. Our intelligence may give us tools to adapt, but intelligence doesn't guarantee survival forever. conditions change, and eventually even the most dominant species must yield. Yet extinction doesn't mean erasure. When a species vanishes, traces remain. Fossils, imprints, chemical signatures in rocks, even genetic material passed on through descendants or relatives. The story of life is written in these remnants. Every extinction leaves a record, a clue for those who come later to piece together. In that sense, extinction is less of an ending and more of a rewrite. The words may change, but the book continues. And there's another lesson here. Extinction is often framed as tragedy, and for us in the short span of human perspective, it is. When we lose species today, whether it's rhinos or tigers or coral reefs, it feels like a devastating blow. And it is, for us, for ecosystems, for the creatures themselves. But in the long span of Earth's history, extinction is transformation. It's how the planet renews itself. This doesn't mean we should shrug off modern extinctions. Far from it. Our responsibility is to care for the world we live in, to preserve the beauty and diversity around us. But it does mean we can recognize extinction as part of the larger rhythm of life, a rhythm that has been playing for billions of years. Perhaps the hardest part of this truth is recognizing that humans too are temporary. It's not easy to think about our own extinction. It feels personal in a way that the disappearance of dinosaurs or trilobites does not. But the logic is the same. One day, whether through gradual decline or sudden catastrophe, our species will vanish. Maybe it will be climate change, maybe disease, maybe something we can't predict. Maybe it will take a few thousand years, maybe a few million. Either way, the odds are not in our favour. Survival forever is not on the table. And yet, just like all the species before us, we will leave traces. Maybe future life will find our fossils, our buildings, our plastics buried in sediments. Maybe they'll puzzle over our existence the way we puzzle over dinosaurs. Maybe they'll wonder if we saw ourselves as permanent and if we understood how temporary we really were. That, in a way, is the gift of thinking about extinction. It forces us to confront impermanence, to see ourselves not as the climax of life, but as one act in a much longer play. It can feel unsettling, but it can also be liberating. Because if permanence was never an option, then the meaning of our existence isn't found in forever. It's found in the here and now, in the way we live during our brief chapter. And so, the story of life continues, written by extinction as much as by survival. Trilobites vanish, dinosaurs vanish, mammoths vanish. Something new always rises to take their place. Life rewrites itself constantly, turning pages again and again. And humans, for all our intelligence and ambition, are not exempt. We're part of the same cycle. The question isn't whether the page will turn, it's when, and what comes after. After the devastation of the Great Dying at the end of the Permian period, life on Earth was forced to start again almost from scratch. The oceans had lost the majority of their species, the land was emptied of its dominant animals, and ecosystems everywhere were shattered. But extinction, as brutal as it is, always leaves open space for something new. And what rose to fill that space would become some of the most iconic creatures in the history of the planet, the reptiles that we now group under the broad, familiar banner of dinosaurs. It didn't happen overnight. In the early stages after the Permian extinction, the world was populated by survivors and opportunists. Reptiles diversified quickly, experimenting with new forms and body plans. Some were small and nimble insect eaters, others heavy-bodied herbivores. Amphibians still clung to rivers and swamps, though they no longer held the dominance they once had. The stage was unsettled, a kind of evolutionary free-for-all, where different groups competed to take over niches left vacant. Then, over millions of years, one group began to stand out. The archosaurs, a lineage of reptiles that included crocodiles and eventually dinosaurs, began to dominate. Their bodies were efficient, their legs positioned under them instead of sprawling out to the sides, which gave them better endurance and speed. They were adaptable, varied, and resilient. Little by little they took over. By the time the Triassic period gave way to the Jurassic, dinosaurs had become the undisputed rulers of the land. If you could walk into that world, the difference would be overwhelming. Towering herbivores with necks longer than buses grazed on cycads and conifers. Predators the size of trucks stalked through forests and plains. Even the air and sea were filled with reptilian rulers, pterosaurs wheeling through the skies on leathery wings, marine reptiles like ichthyosaurs and plesiosaurs prowling the oceans. It was truly the age of reptiles, with dinosaurs at the centre of it all. What made dinosaurs so successful? Part of the answer lies in their sheer diversity. Not all dinosaurs were enormous, though we tend to remember the giants. Some were the size of chickens, darting quickly through undergrowth. Others lived in herds, travelling across vast landscapes in search of food. Some developed feathers, originally for insulation or display, long before they were used for flight. Their adaptability meant they could occupy almost every ecological role imaginable, and they lasted a long time. Dinosaurs reigned for more than 150 million years. To put that in perspective, modern humans have existed for about 300,000 years. Our entire species' history would barely register as a fraction of a percent of the dinosaur era. When you think about dominance in terms of longevity, dinosaurs were unimaginably successful. Their world wasn't static. Climates shifted, continents drifted, sea levels rose and fell. Yet dinosaurs endured through it all. They survived smaller extinction events, adapted to new environments, and continued to evolve. They were not fragile rulers. They were resilient, patient, and remarkably capable of weathering change. It's worth noting that dinosaurs weren't just giant lizards, as early scientists once thought. They were an incredibly varied group with complex behaviours. Evidence suggests many cared for their young, building nests and protecting hatchlings. Some travelled in herds, suggesting social structures. Others developed elaborate crests and frills, perhaps for communication or display. Their lives were not so different in some ways from the animals we know today. And then, after ruling the Earth for longer than we can really grasp, their age came to an end. Around 66 million years ago, an asteroid struck near what is now the Yucatan Peninsula. The impact released energy equivalent to billions of atomic bombs, throwing debris into the atmosphere and blocking sunlight. Plants died, ecosystems collapsed, and the non-avian dinosaurs disappeared. In the space of a geological moment, their reign ended. Yet, as always, extinction didn't erase everything. Birds are the direct descendants of small feathered dinosaurs. In that sense, dinosaurs never fully vanished. They still fly above us today, singing in trees, gliding over oceans, perching on rooftops. The age of dinosaurs transformed into something else, but the lineage continued. When we think about what this means for us, the lesson is sobering. If dominance were enough to guarantee permanence, dinosaurs would still be here. They had size, strength, diversity, and resilience. They lasted longer than any human civilization ever will, and yet they too fell. An asteroid, an accident of fate, was enough to end their age. That reminder brings us back to the central idea of our exploration. If dinosaurs, the giants of history, were ultimately temporary, why would humans be different? Our intelligence, impressive though it is, doesn't shield us from the realities of extinction. We live on a planet that is unpredictable, shaped by forces far beyond our control. Just as dinosaurs were undone by a rock from space, so too could we be undone by disasters or by our own actions. But it's not all bleak. The story of the dinosaurs also shows that endings create beginnings. Without their extinction, mammals might never have risen to prominence. Without mammals, primates wouldn't have appeared. Without primates, humans would not exist. In a strange way, we owe our existence to the asteroid that ended the age of dinosaurs. Their loss was our opportunity, and that cycle will continue. One day, humanity may fade, but whatever comes after us will build on the space we leave behind. Just as birds carry on the lineage of dinosaurs, some future species may carry forward traces of us, perhaps not directly, but as part of the ever-turning wheel of life. So when we look back on the reign of the dinosaurs, it's not just a story of giant reptiles. It's a story of impermanence, of how even the mightiest rulers are subject to change. It's a story that mirrors our own, reminding us that no chapter in Earth's history lasts forever, no matter how powerful it seems at the time. While the dinosaurs ruled the land with their towering bodies and thundering steps, another group of creatures lived quietly in the background. They were small, they were unremarkable by the standards of the time, and they didn't dominate any ecosystem. These were the mammals, fragile in appearance but patient, waiting in the wings of history. Mammals first appeared during the Triassic period, more than 200 million years ago. At the time, they were tiny compared to the reptiles around them. Most were no bigger than mice, some resembling shrews or opossums. They hunted insects, scavenged what they could, and kept to the shadows. In a world where predators the size of buses stalked the forests, smallness was a survival strategy. Being unnoticed meant being alive. What set these mammals apart was not size, but biology. They were warm-blooded, able to regulate their internal temperatures instead of relying solely on the environment. This gave them endurance and flexibility. They could be active at night when many reptiles slowed down. Their bodies were covered in fur, another adaptation for retaining heat. And, perhaps most importantly, they nursed their young with milk, giving their offspring a better chance of survival during those fragile first stages of life. None of this made them rulers. For more than 150 million years, mammals remained in the background, rarely expanding beyond small ecological niches. But they endured. They lived alongside dinosaurs, beneath their feet, under their shadows, through changing climates, through the rise and fall of species much larger than themselves. They were survivors, and that patience would eventually pay off. Living small also shaped the way mammals developed. Many became burrowers, digging into the ground to escape predators and extreme conditions. Some climbed trees, some scurried through underbrush, others swam in streams. Their variety grew slowly, quietly, without challenging the dinosaurs for dominance. It was not their time to rule, but their evolutionary groundwork was being laid piece by piece. Their brains were another subtle difference. Mammals had larger, more complex brains relative to body size than most reptiles. They developed sharper senses of smell and hearing, adaptations that helped them survive in the dark and avoid predators. Intelligence, in its earliest form, was beginning to take root. It wasn't the intelligence of humans yet, not by a long stretch, but the seeds were there. Then came the moment that would change everything. 66 million years ago, the asteroid struck. The skies darkened, the climate shifted, plants withered, and the dinosaurs, except for the birds, disappeared. The world that had belonged to them for so long was suddenly empty, devastated, and ready for new occupants. Mammals, small and adaptable, were ready. Their size, once a disadvantage in a world of giants, now became an advantage. They needed less food, they could hide, they could reproduce quickly. They filled the niches left open by the dinosaurs. What had once been a world of shadows turned into a world of opportunity. In the millions of years that followed, mammals exploded in diversity. Some grew large, becoming the ancestors of whales, elephants, and bison. Others developed into primates, eventually giving rise to us. The age of mammals had begun, but it was built on a foundation of survival strategies honed during the time of dinosaurs. Without those long ages of quiet persistence, mammals might never have been able to seize their moment. When we think about this part of the story, it's tempting to focus only on the eventual outcome, humanity. But the truth is broader. The mammal's rise was not inevitable, and it wasn't aimed at us specifically. It was simply the result of resilience, of adaptability, of being able to survive where others could not. Mammals were not the most powerful or dramatic creatures, but they were persistent. And sometimes persistence is what history rewards. This is another reminder that humans are not the pinnacle of life, but one branch among many. Our existence rests on a chain of accidents, extinctions and adaptations stretching back hundreds of millions of years. The dinosaurs fell, mammals rose, and eventually primates emerged. But if history had taken even slightly different turns, the outcome might have been entirely different. Even now, many of the traits that allowed early mammals to thrive are still with us. We are warm-blooded, we care for our young, we have complex brains, we can adapt to different environments. But just as those traits didn't guarantee permanence for mammals in the long run, they don't guarantee permanence for us either. We are temporary inheritors of their strategies, not eternal masters of them. In the quiet persistence of early mammals, there is a lesson. Survival doesn't always belong to the biggest or the strongest or the most dominant. Sometimes it belongs to those who endure quietly, who adapt patiently, who wait for the right moment. Mammals did that for more than 150 million years, and when their moment came, they were ready. And so, as we consider humanity's place in Earth's story, it's worth remembering that we began not as rulers, but as survivors. Our ancestors were not kings of the landscape, but small, unnoticed creatures hiding in shadows. We carry that legacy with us, even if we rarely think about it. When mammals had spread across the earth and carved out their place after the fall of the dinosaurs, one branch began a slow journey that would eventually lead to us. It didn't happen quickly, and it didn't happen with the inevitability we sometimes imagine. There was no guarantee that primates would rise, no certainty that intelligence would blossom into something more. But piece by piece, through chance, environment and adaptation, our ancestors found themselves on a path that would eventually create what we now call humanity. Our beginnings were fragile. The earliest hominins, appearing in Africa a few million years ago, were not kings of their world. They were small compared to the predators around them. They lacked sharp claws, heavy armor, or great speed. Survival wasn't easy. They lived in shifting environments, where forests gave way to grasslands, where water sources moved, where food wasn't always predictable. In that landscape, survival depended less on brute strength and more on flexibility. One of the first sparks that set our lineage apart was the ability to use tools. Even before us, primates like chimpanzees had used sticks to fish termites from mounds or stones to crack nuts. But early humans began shaping stones deliberately, crafting edges for cutting, chipping them to make sharp points. This may not sound dramatic, but it opened new possibilities. With tools, our ancestors could butcher animals, cut plants more efficiently and defend themselves more effectively. It was a small step toward controlling the environment rather than being entirely at its mercy. Then came fire. It's hard to overstate how transformative fire was. The earliest controlled use of fire is debated, but evidence suggests it stretches back hundreds of thousands of years. Fire provided warmth in cold nights, protection from predators, and a way to cook food. Cooking, in turn, unlocked more nutrients from meat and plants, fueling larger brains and more energy for survival. Fire was not just a tool, it was a force multiplier, something that expanded the boundaries of what was possible. Fire also changed the rhythm of life. Before fire, night was dangerous and limiting. After fire, humans could extend their days, gathering around flames, sharing food, telling stories. Some anthropologists suggest that language itself may have developed more fully in those hours by the fire, when people had time to communicate beyond immediate needs. Whether or not that's true, fire created space for culture, for reflection, for something more than survival. Language itself was another spark. It didn't appear all at once. Gestures, sounds, and expressions likely formed the earliest layers of communication. But over time, these grew into something structured, flexible, and powerful. With the language, humans could share knowledge beyond the here and now. They could teach, plan, imagine, and coordinate in ways no other species had done before. Language allowed memories to be stored not just in brains, but in communities. It was the beginning of culture in the fullest sense. These two sparks, fire and language, changed everything. They gave early humans tools to survive in harsh conditions, to expand into new territories, and to build social bonds stronger than any single individual's abilities. But it's important to remember how fragile it all was. Our ancestors were never guaranteed success. They were vulnerable, often on the brink, shaped by droughts, famines, predators, and disease. Small groups huddled together, moving across landscapes, often facing the risk of disappearing entirely. Many did. Humanity is not a single, uninterrupted line. The family tree of our species is filled with branches that ended. Neanderthals, Denisovans, and many other hominin species once shared the world with us. They were intelligent, skilled, and capable in their own right. Yet, over time, they vanished. Some were replaced by us, some interbred and became part of our genetic legacy. Some faded for reasons we still don't fully understand. Their disappearances remind us that being human was never inevitable. It was one path among many, and it could have ended as easily as it began. Still, the sparks of fire and language carried our lineage forward. They gave us resilience. They let small groups travel farther, adapt to new climates, and push into environments others couldn't. By the time Homo sapiens appeared around 300,000 years ago, those foundations were already in place. The ability to shape tools, master fire, and communicate in complex ways was woven into us. They were the fragile beginnings of what would become civilization. What's striking is how ordinary those beginnings might have seemed at the time. Imagine a group of early humans gathered around a fire. They weren't thinking about the future of the species, or about building cities or writing books. They were warming their hands, cooking food, keeping predators at bay, perhaps laughing or comforting each other. Yet from those simple acts came the foundation of everything we know. And this, again, reminds us that humanity's story is not about destiny, but about chance and fragility. We rose not because we were guaranteed to, but because small advantages accumulated over long stretches of time. Fire was discovered, language evolved, culture took shape. Each step built on the last, often in ways no one could have predicted. Our beginnings also show how dependent we are on cooperation. Early humans could not have survived alone. Fire needed tending, food needed sharing, children needed protecting. Language made that cooperation stronger, but the instinct to live together was always part of our survival. Humans are social not because it's pleasant, but because it was necessary. So when we ask whether humans are the pinnacle of life or just a phase, it helps to look back at how fragile those first sparks were. We were never inevitable. We were never destined to last forever. We are the result of small survivors who learned to endure, who found sparks in fire and language, who managed to build something more than survival. And those sparks, though powerful, don't guarantee permanence. Fire can burn out. Language can fade. Cultures can collapse. Just as they began, they can end. Once fire and language gave us a foothold, humanity's story began to accelerate. For hundreds of thousands of years, the pace of change was slow. Tools shifted only gradually. Lifestyles remained tied to hunting and gathering, and survival was still precarious. But somewhere along the way, the tempo quickened. Inventions built on each other. Knowledge accumulated, and what once took millennia to change began to shift in centuries, then decades, then even faster. From the first chipped stones to orbiting satellites, the acceleration of human history has been staggering. It started small. Sharpened stones became spears and axes. Humans learned to fasten points to wooden shafts, turning simple rocks into weapons with range and force. Hunting became more efficient, defense more effective. With spears, groups could take down larger prey, feed more people, and expand into new environments. The balance between humans and the world around them began to tilt ever so slightly in humanity's favour. Then came the bow and arrow, a leap that added precision and distance to survival. Now hunters could strike from farther away, reducing risk and increasing success. Small innovations like these compounded, and with each one, humans gained more control over their circumstances. But the real shift came with agriculture. Around 10,000 years ago, in several places across the globe, humans began to domesticate plants and animals. Farming replaced foraging. Instead of moving constantly in search of food, people stayed in one place, planting seeds, tending crops, raising herds. This was a turning point as dramatic as fire. It allowed for surplus food, larger populations, permanent settlements, and eventually cities. With agriculture came new tools: ploughs, irrigation systems, grinding stones. With cities came walls, roads, and marketplaces. With larger populations came hierarchies, governments, and organized religions. Every step of the way, the pace of change quickened. Writing appeared first as marks on clay tablets, then as alphabets carved into stone, painted on papyrus, inked on parchment. Language, once only spoken, now became visible, permanent, and transferable across time. Knowledge no longer lives solely in memory. It could be recorded, shared, preserved. This was another spark that accelerated everything. Civilizations rose and fell, each leaving behind contributions that built on what came before: the wheel, mathematics, astronomy, medicine, architecture. Trade connected distant lands, spreading ideas as well as goods. Wars pushed technology forward in brutal ways, while peace allowed for art and science to flourish. Humanity was no longer simply surviving, it was reshaping the world. Metalworking transformed tools and weapons. Bronze, then iron, then steel gave humans stronger materials to build with and fight with. Ships carried explorers across seas. Compasses, maps, and navigation tools shrank the world, linking continents. Printing presses multiplied books, spreading ideas faster than ever before. Telescopes revealed the scale of the cosmos, microscopes the hidden worlds within a drop of water. And then, in just the last few centuries, the acceleration became almost dizzying. The Industrial Revolution turned coal and steam into engines of power, moving machines that transform production, transportation, and daily life. Trains shrank distances on land. Steamships did the same at sea. Factories rose, cities grew, and populations exploded. Electricity arrived, lighting up nights, powering inventions, driving communication. Telegraphs sent dots and dashes across continents. Telephones carried voices across wires. Radios transmitted sound through the air. Then came motion pictures, airplanes, automobiles. Each invention shrank the world further, speeding up not only travel and communication but the pace of life itself. In less than 2 centuries, humanity went from horse-drawn carts to jet engines, from handwritten letters to instant messages. Knowledge exploded, discoveries piled on discoveries, and the trajectory tilted upward faster and faster. And then space. Rockets, first designed for war, carried satellites into orbit. Humans set foot on the moon. Spacecraft explored planets. Telescopes captured light from galaxies billions of years away. What had once been stories told under the stars around campfires became realities. In only a few thousand years, a blink compared to the age of the Earth, humans had gone from chipped stone spears to satellites circling the planet. This acceleration is unlike anything else in the history of life. No other species has reshaped its environment, its tools, and its knowledge at such speed. But the very pace that defines us also raises questions. How sustainable is this acceleration? Can it continue indefinitely? Or will it, like so many other rises in Earth's history, eventually plateau or collapse? Because with acceleration comes risk. The same tools that allowed us to thrive also give us power to destroy. Fire once kept us warm and safe, but it also burned forests. Agriculture fed millions but altered ecosystems. Industrial revolutions built prosperity but filled the skies with carbon. Satellites link the world but also track weapons and conflicts. Each advance carries both possibility and danger, creation and destruction. And it's worth remembering that while our acceleration feels monumental to us, in Earth's larger story it may be temporary. The dinosaurs ruled for 150 million years without inventing wheels, roads or rockets, and yet they too vanished. Mammals lived in the shadows for over 100 million years before rising. Our acceleration might be remarkable, but it doesn't guarantee permanence. Still, there is something unique in what we've done. Fire, language, agriculture, science. Each one is layered upon the other, speeding us forward. We've gone from slow walkers on the savannah to explorers of space in a fraction of Earth's history. It is breathtaking when you pause to think about it. And it leaves us with a question. Is this acceleration the sign of humanity's lasting importance? Or is it simply another brief burst before the planet moves on? History suggests the latter. But for now, we live in the middle of it, racing forward from spears to satellites, watching the world change faster than ever before. As humans move from small groups of hunters and gatherers into larger, more organised communities, the planet began to change in ways it never had before. Fire and language had given us survival, agriculture had given us stability, and acceleration through tools and machines had given us momentum. But it was when we began building permanent settlements, sprawling cities, and systems of trade and industry that the Earth itself started to bear our signature in undeniable ways. Our presence became visible not just in artifacts and fossils, but in the very surface of the planet. Cities are one of the clearest marks of our species. From their beginnings, they represented something more than just clusters of homes. They were centres of culture, governance, trade, and technology. Jericho, Uruk, and Mohenjo-Daro stand among the earliest known examples, thousands of years old, where people gathered in numbers larger than any single family group could sustain. Once humans began clustering together, specialization emerged. Some grew food, some built structures, some crafted tools, some governed. This division of labor created complexity, and complexity created momentum. Stone gave way to brick, mud gave way to marble, wood gave way to steel and glass. Cities rose and fell, some leaving ruins that still inspire awe, others leaving only faint traces in the ground. Yet the idea of the city persisted. Today, more than half of the world's population lives in urban environments, and the glow of human settlement can be seen from orbit. It is one of the clearest signals that Earth is a planet touched deeply by a single species. But cities are only one part of the stamp. The way we have altered the chemistry of the atmosphere is another. When humans began burning wood and later coal, oil and gas to power our machines, the balance of carbon dioxide in the air began to shift. It was a small change at first, almost invisible. But as industries grew, as cars multiplied, as power plants spread, the scale of carbon emissions increased. Today, the concentration of carbon dioxide in the atmosphere is higher than it has been in millions of years. This single fact links us directly to the fate of the planet's climate. The warming we're seeing, the melting glaciers, the shifting weather patterns, they're all part of our stamp. No other species has ever altered the atmosphere in this way, and it will be one of the clearest markers of our existence long after we are gone. Layers of ice and sediment in the distant future will show the sudden spike, the abrupt signal of human industry. Our footprint is also in the landscapes themselves. We cut forests for timber and farmland. We dam rivers to control water. We mine mountains for minerals. We carve highways across continents. Satellites reveal grids of fields, glowing roads, and scarred surfaces that are unmistakably artificial. The planet, once shaped almost entirely by geology, tectonics, and climate, is now reshaped by human hands. And then there is plastic. Created barely a century ago, it now exists everywhere. In landfills, in oceans, in the bodies of animals, in the sediments that will harden into future rock. Future geologists, if they exist, will find plastic as a signature layer, a bright marker of human presence in the geological record. It will be one of the indelible fingerprints of our time, long after our cities have crumbled and our machines have rusted away. Agriculture too has left its mark. Domesticated crops like wheat, corn and rice dominate vast areas of the planet. Domesticated animals like cattle, pigs and chickens exist in numbers that dwarf wild populations. The ecosystems of Earth have been reshaped to serve us, creating a global network of fields and farms that sustain billions. But this reshaping has come at a cost, often reducing biodiversity, replacing complex ecosystems with simplified ones. What is striking in all of this is the speed. Forests once took centuries to expand or contract. Climates once shifted over millennia. Landscapes once changed slowly under the forces of erosion and plate tectonics. But in just a few thousand years, humans have accelerated these processes dramatically. In only a few centuries of industrialization, we have altered the atmosphere, reshaped continents, and redistributed species around the globe. And this raises the question at the heart of our exploration. Does leaving a big stamp mean we are permanent? The evidence from Earth's history suggests otherwise. Trilobites once dominated oceans for hundreds of millions of years, leaving behind vast fossil beds. Dinosaurs stamped their mark in bones, footprints, and even the ecosystems they shaped for over 150 million years. Yet they are gone. Their marks remain, but their reign ended. Our stamp may be clear, but clarity does not equal permanence. It may mean that the evidence of us will linger in plastics, in carbon layers, in altered landscapes, but it doesn't mean we ourselves will endure. In fact, the scale of our changes may even hasten our decline. Altering the climate, reducing biodiversity and straining ecosystems could make survival more difficult in the long term. Still, there is something undeniable about the way humans have inscribed themselves on Earth. From orbit, the lines of cities shine like constellations. From deep time, our alterations to carbon and chemistry will remain as signals. Our roads, our dams, our waste, our monuments. They are the marks of a species that moved quickly, that accelerated through history, that reshaped its planet in ways no creature had before. Whether that makes us a pinnacle or simply another temporary phase is the question we return to again and again. History leans toward the latter. Our stamp may be bold, but it is written in the same book as every other species, subject to the same turning of pages, the same inevitability of change. There's a term that has gained traction in recent years, one that carries both weight and unease. It's the word Anthropocene, meant to describe a new epoch in Earth's timeline where human activity is the defining force shaping the planet. It suggests that we, through our cities, our machines, our carbon, and our consumption, have altered the world so deeply that we've created a geological age named after ourselves. It's an idea that flatters us, but also one that might mislead us if we're not careful. Because behind the word lies an assumption, one that has quietly worked its way into human thought, that we are the final chapter in Earth's story, that the arrival of our species marks a culmination, a climax, the point toward which history has always been heading. And while it is tempting to believe this, the evidence of Earth's past tells us a different story. The Anthropocene illusion begins with scale. We look at our impact, the altered atmosphere, the plastics, the cities visible from space, and it feels enormous. Compared to the delicate lives of our ancestors huddled around fires, our power today seems unmatched. We've moved mountains, drained rivers, altered coastlines, even split the atom. It feels as though nothing before us could rival what we've done. But scale can deceive. The cyanobacteria that flooded the atmosphere with oxygen billions of years ago reshaped the entire biosphere, paving the way for complex life. Forests of the Carboniferous age altered the planet's chemistry and left behind the coal seams we still burn. Dinosaurs dominated the land for over 100 million years, transforming ecosystems on a scale we can barely imagine. Compared to them, our few thousand years of industry are brief scratches on the surface. The illusion also comes from immediacy. We live in the now, and the changes we witness in our lifetimes feel monumental. When ice sheets shrink, when forests are cut down, when species vanish, we sense finality. But in the measure of geological time, even centuries are moments. The asteroid that ended the dinosaurs rewrote life in an instant, compared to the usual pace of Earth's rhythms. The shifts we see today may be dramatic for us, but for the planet they are part of a long continuum, one that has no reason to end with us. There's also a kind of pride hidden in the Anthropocene label. It suggests that we are unique, that we've finally become a force as significant as volcanoes or tectonic plates. In a sense, that's true. No other species has burned fossil fuels, launched satellites, or left footprints on the moon. But uniqueness is not the same as permanence. Trilobites were unique once, so were ammonites. So were the great reptiles of the Permian and the towering mammals of the Pleistocene. Each of them had qualities that set them apart. Each of them dominated their world in ways that seemed absolute. And yet each of them became another page turned. What the Anthropocene illusion does most effectively is feed the belief that history has direction, that everything before us was leading to this point. But Earth's history has never been about direction. It has been about change, about adaptation, about the ebb and flow of life under shifting conditions. If anything, the story is one of constant resets, of eras rising and falling, of experiments beginning and ending. To think of ourselves as the final chapter is to ignore the countless chapters that came before and the countless that are likely still to come. It's worth remembering that our presence here depends on events that had nothing to do with us. The asteroid that cleared the dinosaurs' reign opened a path for mammals. The rise of oxygen allowed for the possibility of complex life. The stability of climate during the Holocene gave agriculture a chance to flourish. None of these were planned, none of them aimed toward humanity. They were accidents of history, convergences of chance. To assume that those convergences were meant to produce us, and only us, is to mistake coincidence for destiny. And yet the Anthropocene illusion persists because it feels real in daily life. When we see mega cities glowing at night, when we know our carbon shapes the weather, when we measure the spread of our species into every corner of the globe, it is hard not to feel like the story has reached its climax. We are everywhere, we are powerful, we are inescapable. But so too were the dinosaurs in their age, and so too were the trilobites before them. The Earth has a way of humbling its dominant forms, and it does so without sentiment. This doesn't mean our impact is trivial. On the contrary, what we do now will shape the near future in ways that matter enormously to us and to countless other species. The ecosystems we alter, the climate we drive, the extinctions we accelerate, these are profound. But they are profound in the scale of human history, not in the permanence of Earth's. 10 million years from now, whether humans still exist or not, the planet will have moved on. New species will fill the gaps. New systems will evolve. New rhythms will take hold. Our chapter, however dramatic, will have passed into memory. Perhaps the deepest danger of the Anthropocene illusion is that it makes us complacent. If we see ourselves as the final chapter, we may feel untouchable, as though nothing could erase us. But history shows otherwise. Our intelligence is remarkable, but it doesn't protect us from asteroids, supervolcanoes, pandemics, or even our own choices. We are not insulated from the forces that ended every age before us. There is another way to look at the Anthropocene, not as a declaration of permanence, but as a recognition of responsibility. if we are powerful enough to alter the planet, then we are also responsible for the consequences. The illusion fades when we accept that our chapter is temporary. But in that temporary span, we can choose how it unfolds. We can choose whether our legacy is destruction or resilience, whether our mark deepens harm or fosters survival. When we see the Anthropocene clearly, without the illusion, we recognize ourselves as part of a much larger narrative. We are not the climax of Earth's story, but a moment within it. A moment capable of great impact, yes, but still a moment. And when that moment passes, as it inevitably will, the story will continue without us. When we think about dominance, it's easy to imagine it as something solid, something that, once achieved, will last. We look at great cities, powerful nations, and sprawling empires, and they seem unshakable. Their monuments rise above landscapes, their armies march across borders, their influence stretches beyond their own lifetimes. But history has a way of showing us that dominance is fragile. Every civilization, no matter how mighty it once appeared, has eventually cracked and fallen. The earliest civilizations remind us of this. Take Mesopotamia, often called the cradle of civilization. It was here that humans first built cities, developed writing, and organized large-scale agriculture. For centuries, city-states like Uruk, Ur, and Babylon thrived. Their walls seemed impenetrable, their temples eternal. Yet floods, droughts, invasions, and internal struggles weakened them again and again. Kingdoms rose, but none lasted forever. Today, the ruins of those cities are silent reminders that permanence was never theirs. Egypt, with its pyramids and pharaohs, seemed immortal to those who lived under its rule. The Nile provided food, trade, and stability. Dynasties endured for thousands of years, a span longer than most other civilizations could dream of. And yet Egypt too fractured, absorbed by foreign powers, transformed into something else. Its monuments still stand, but the culture that built them is long gone. Rome is another striking example. At its height, the Roman Empire stretched across Europe, North Africa, and the Middle East. Its roads, aqueducts, and laws bound millions together. Roman legions enforced its will. Roman architecture reshaped landscapes. Roman culture seemed unstoppable. But over time, pressures mounted. Corruption, economic strain, overexpansion, and waves of invasions eroded its strength. Eventually Rome split, weakened, and collapsed. Its ruins remain, its ideas echo in our institutions, but the empire itself became history. What these examples show is that dominance is never as permanent as it feels in the moment. Civilizations often crumble under a mix of pressures, both external and internal. Sometimes it's environmental, drought, famine, disease. Sometimes it's political, corruption, inequality, unrest. Sometimes it's military, invasions, uprisings, wars. Often it's all of these together, weaving a web of fragility beneath a facade of strength. The Mayan civilization built vast cities in the forests of Mesoamerica, with towering temples and sophisticated knowledge of astronomy. For centuries they thrived, creating art, architecture, and systems of governance. But eventually environmental stress, deforestation, and prolonged drought combined with internal conflict to unravel them. Their great cities were abandoned, left to be swallowed by the jungle. The same pattern appears in countless places. The Indus Valley civilization, advanced for its time, disappeared for reasons still debated, likely a mix of climate shifts and changing rivers. The Anasazi of the American Southwest built remarkable cliff dwellings, only to move on after droughts made survival impossible. Civilizations large and small rise with energy and optimism, but over time cracks appear, and the weight of those cracks brings them down. If we look closely, the fragility of dominance is not an exception, but a rule. No system, no matter how advanced, is immune to collapse. And this brings the lesson directly to us. Because if Egypt, Rome, Mesopotamia, and countless others could fall, What makes us think our global civilization is immune? Today, our dominance feels more secure than ever. We have technology that links the world instantly. We have cities larger than the entire nations of the past. We have medicine that cures diseases once fatal, machines that span the skies, satellites that orbit the Earth. We produce food on massive scales. We control rivers. We reshape landscapes. But so too did the great civilizations of the past feel secure, right up until they didn't. Our vulnerabilities are not so different from theirs. Climate change threatens agriculture and stability, just as droughts weakened past societies. Political divisions, inequality, and corruption strain governments, just as they did in Rome. Conflicts and wars destabilize regions, as they always have, and in addition to these old threats, we face new ones: nuclear weapons, global pandemics, and technological risks that earlier civilizations never imagined. Dominance, in the end, is always fragile because it relies on balance. Balance between people and environment, between rulers and ruled, between expansion and sustainability. When balance breaks, cracks widen. Once those cracks grow, even the strongest walls fall. This is not to say collapse always erases everything. When civilizations fall, they often leave behind fragments that shape the next. Rome's laws influenced Europe for centuries. Egypt's monuments inspired generations. Mesopotamia's writing gave us alphabets. The fall of one society can clear the way for another, just as the extinction of one species makes room for the rise of another. Endings feed beginnings. But it does mean that we should view our own dominance with humility. Our skyscrapers, our power grids, our internet, they may feel eternal, but so too did the pyramids, the aqueducts, the temples, and the libraries of past ages. Time showed that nothing built by human hands is beyond decay. The fragility of dominance reminds us that permanence is an illusion. We are not immune to the forces that undid every civilization before us. We live in a chapter of abundance and connection, but history suggests it will not last forever. One day, our cities too may fall silent, our monuments weather, our systems unravel. The earth will continue, but our dominance will fade. When we think about a world after humanity, it can feel like a grim exercise, a vision of absence and silence. Yet if we shift the perspective away from us and back onto the planet itself, the story becomes less about endings and more about transformation. Because Earth has seen countless eras come and go, countless rulers rise and fall, and through it all it has healed, adapted and rewilded in ways that surpass what any single species imagines while it's here. If humanity were to vanish, Earth would not pause, it would change. The first days and weeks after us would carry traces of sudden stillness. Cities would remain, lights would flicker until grids failed, airplanes would fall silent, cars would stall on empty highways. Without people to tend them, power plants would shut down, water systems would dry or flood, and buildings would begin their slow surrender to weather. Pets and livestock would roam or struggle depending on their environments. For a brief moment the world would seem frozen in the shape we left it, like a stage abandoned mid-performance. But already, the processes of healing would begin. Plants would be the first to reclaim what we built. Cracks in pavement would widen as roots pushed through. Vines would creep up walls. Grasses would spread across empty lots. Trees would seed themselves in open spaces. Within a few decades, most cities would be softened by greenery. Without constant clearing, forests would return where we once farmed. Prairies would spread where highways cut across the land. Wetlands would reform where rivers had been dammed. The planet has always been ready to cover scars once pressure is released. Animals too would move back into places we kept them from. Wolves and bears would reclaim forests in Europe and North America. Elephants might roam farther in Africa and Asia without poachers and fences. Deer, foxes and wild boars would thrive in abandoned suburbs. Birds would nest in crumbling towers, bats in tunnels, owls in attics. Species that had been pushed to the margins would expand again, filling the niches we once dominated. Oceans would begin to recover from centuries of overfishing. With no trawlers dragging nets, fish populations would rebound. Whales would migrate freely without ships to collide with or sonar to disrupt them. Coral reefs, though stressed by warming and acidification, might have a chance to stabilize if carbon levels declined over millennia. Life in the seas has always been quick to adapt when pressure is lifted, and given time, it would flourish again. Carbon itself would take longer to balance. The atmosphere we have altered would not reset overnight. But forests regrowing on abandoned farmland would absorb some of it. Soils would lock away more. Over centuries, the planet would slowly draw down excess carbon. Ice sheets might still retreat or vanish in the near term. Seas might still rise, climates might still shift. But without us burning fuels and clearing forests, new equilibria would form. Life would continue, reshaping itself to fit the changed world, just as it has after every past upheaval. Our monuments would not last forever. Glass towers would shatter, steel would rust, concrete would crumble. Within 1,000 years, few modern buildings would still stand intact. Within tens of thousands of years, even the grandest cities would be ruins buried under soil and forest. Only the most durable structures, stone monuments, underground tunnels, perhaps the carved faces of mountainside statues, would linger as faint echoes of us. Plastics, oddly, might be our longest-lasting trace, embedded in sediments and forming strange new composites. In the long arc, life would not just return but diversify. Evolution would continue. New species would emerge. Ecosystems would grow in complexity. Perhaps birds would radiate into new forms, or mammals would evolve traits we can't imagine. Perhaps some surviving primates would grow more intelligent over millions of years, repeating in their own way the experiment of consciousness. Or perhaps entirely different lineages, cephalopods, insects, reptiles, would find paths into new dominance. The future would be as open and surprising as the past has always been. Rewilding is not just about ecosystems, but about balance. Without human industry, rivers would meander back into old courses, wetlands would spread, coastlines would shift naturally. The noise of machines would vanish, leaving soundscapes of wind, water, and animals. Night skies would darken without artificial light, stars shining again as they did for most of Earth's history. The rhythms of the planet would return to cycles of sun, moon, tide, and season, without interference from electric grids or industrial schedules. This doesn't mean the Earth would return to some imagined pristine state. The traces of us would remain, in altered climates, in redistributed species, in geological layers. Invasive species we spread would still exist in places far from their origins. Domesticated animals might adapt into wild forms or fade away. The scars of mining and waste might linger for millennia. But the overall story would be one of adaptation, of life weaving around what we left, of nature filling the spaces we no longer occupy. And so, a world after humanity would not be barren but abundant. It would be quieter in human terms, but louder in natural ones. Forests would whisper, oceans would teem, animals would roam. It would be a world healing itself, not out of intention, but out of persistence. Because Earth has never needed us to thrive. Life existed for billions of years before us, and it will exist for billions after us. This perspective reframes our place. Rather than seeing ourselves as the final guardians of the planet, we can see that the planet carries on regardless. Our presence is a phase, our dominance a moment. If we vanish, the story does not end. It simply shifts. The idea of Earth healing and rewilding after us may sound humbling, even unsettling, but it can also be comforting. It reminds us that life is resilient, that the planet has endurance beyond any single species. It reminds us that while we may leave scars, time and life will cover them. It reminds us that endings for us are not endings for Earth. When people imagine the end of humanity, one of the most persistent questions follows quickly behind. If we disappear, could something like us ever rise again? Not exactly humans, of course, but intelligence of a similar kind. The ability to reason, to build, to speak, to reshape the environment with thought and intention rather than instinct. Is intelligence a rare accident that will never repeat? Or is it one of evolution's drafts, an idea so useful that it might appear again and again until the conditions are right? To even think about this, we first need to understand how unlikely our own path was. Our brains did not emerge fully formed, nor was there any grand plan guiding them. They were the product of a series of pressures: survival in shifting climates, the need for cooperation, the benefits of communication, the usefulness of tools. Our intelligence was an accumulation, not a leap. Millions of years of small steps layered into something that, when we look back, feels extraordinary. But to the Earth, it was just another adaptation. Other species have shown glimmers of this path. Crows and ravens use tools, bending twigs to fish out insects, dropping nuts onto roads for cars to crack. Octopuses solve puzzles, escape enclosures, recognize individuals. Dolphins communicate in complex patterns, teaching behaviors across generations. Elephants display memory and empathy, mourning their dead. These are not small signs. They show that intelligence is not ours alone, that the seeds of it exist across the tree of life. But seeds do not always grow into forests. Many of these species are constrained by their bodies, their environments, or the pressures they face. Octopuses are brilliant, but their short lifespans limit cultural transmission. Crows are clever, but wings and beaks make it harder to build complex technology. Dolphins are social, but the ocean environment restricts fire, metal, and construction. In each case, intelligence shines, but conditions keep it from expanding in the way it did for us. So the question is not whether intelligence could appear again. It already has, in smaller ways. The question is whether it could accumulate into something world-shaping, and for that the key may be the same as it was for us: environment, cooperation, and chance. If humans were gone, the niches we once filled would be open. Species that thrive in social groups, that can manipulate their environments, that have long lifespans and capacity for learning, would have opportunities. Primates might once again evolve toward higher intelligence. Given millions of years, a new lineage of apes could develop larger brains, more complex communication, and eventually even culture. But perhaps it wouldn't be primates. Maybe corvids, already showing remarkable problem solving, could evolve further if freed from the pressures that keep their populations in check. Maybe cephalopods, if oceans remain stable for long enough, could find paths toward longer lives and greater social learning. And then there is the possibility of something we can't imagine. The history of life is filled with surprises. Who would have predicted hundreds of millions of years ago that fish would crawl onto land and become mammals? Who would have predicted that tiny shrew-like creatures hiding from dinosaurs would someday build rockets? Predicting the next step is almost impossible, but the potential is there. Some argue that intelligence was inevitable, that the pressures of survival eventually push species toward it. After all, brains give flexibility, the ability to adapt to new environments, to outthink predators, to exploit opportunities. But others argue the opposite, that intelligence as we know it is a fluke, a rare and fragile convergence. After all, life thrived for billions of years without it. Trilobites ruled the seas without language. Dinosaurs dominated for over 100 million years without building cities. If intelligence were inevitable, why didn't it appear more often? The truth may be somewhere in between. Intelligence in the broad sense, problem-solving, communication, memory, seems common. But intelligence on the scale of humans, capable of reshaping an entire planet, may be rare. It required not just brains, but bodies capable of using tools, environments that rewarded cooperation, and long enough lifespans to pass knowledge on. The right combination is not guaranteed, but it is also not impossible. If intelligence were to return in some form, it would likely look very different from ours. Another species might not use fire or metal, but some other resource we overlook. Their communication might not be spoken language, but patterns of colour, gesture, or sound we cannot imagine. Their societies might not build skyscrapers, but something entirely new. Intelligence does not have to follow our blueprint. It can take many forms, shaped by the bodies and environments that produce it. This raises another thought. If intelligence emerges again, would it repeat our mistakes? Would it burn through resources, alter climates, dominate ecosystems? Or would it find different paths, guided by different pressures, perhaps more balanced or perhaps equally destructive? Intelligence gives power, and power always reshapes the world. But how that reshaping plays out depends on choices, and those choices would not be ours. Looking at our own history, we can see that intelligence is both a gift and a burden. It gave us art, science, exploration, and connection. It also gave us war, exploitation, and environmental collapse. If evolution writes a second draft, it may emphasize different traits. Maybe empathy and cooperation would be more central. Maybe efficiency rather than expansion. Or maybe the same cycle of rise and fall would play out, because intelligence is always walking a line between creation and destruction. The possibility of intelligence returning also humbles the idea that we are unique. Yes, we are the only species to have done what we've done, but uniqueness is temporary. Once ammonites were unique. Once trilobites were unique. Once dinosaurs were unique. Our uniqueness may be nothing more than another draft in a long series, and drafts by definition can be rewritten. So, could intelligence return? The honest answer is yes, given enough time, but not in the way we imagine. Not another humanity, not another version of us. Something else. Something shaped by its own pressures, its own histories, its own chance convergences. It might happen in 10 million years, or 50, or never at all. The Earth is patient. It does not hurry. And that patience is what makes the question so fascinating. From the perspective of deep time, our story is brief, but time leaves room for countless experiments, countless second drafts. Intelligence may rise again, not because it must, but because evolution always explores possibilities, and sometimes, in those explorations, the extraordinary happens. When we think about intelligence, we almost always picture it in our own shape. We imagine hands capable of holding tools, eyes facing forward, voices carrying language. We imagine thought as something that looks like ours, because it's all we've ever known. But if humanity were to vanish and another form of intelligence were to rise, there is no reason to assume it would mirror us. Minds are not bound to a single blueprint. The way we think is only one version among countless possible versions. Consider the octopus again. Its nervous system is spread through its body, with neurons not just in its head but in its arms. When an octopus explores, it is not just a brain issuing commands, but arms acting with their own measure of autonomy. It is a distributed kind of intelligence, one where decision-making is shared across the body. If such a system evolved further, what would consciousness feel like in a being that does not centralize thought but spreads it out? Would such a mind even have a sense of self as we know it? Or would it experience existence as a more fluid, collective awareness of its parts? Birds offer another clue. Corvids and parrots, with their small but efficient brains, demonstrate problem-solving, tool use and memory. But their minds are tied to flight, to three-dimensional navigation, to social calls that span vast distances. If intelligence in birds expanded further, Their thought might be grounded not in objects and tools, but in patterns of movement, sound, and air. Their language could be song-like, woven with rhythm and pitch beyond our comprehension. What we call music might be the very core of their thought, not a decoration of it. Then there are dolphins and whales. Their communication systems, though still only partially understood, suggest complexity. Clicks, whistles, and even body language create layers of meaning. Their societies are rich with alliances, teaching, and traditions, but living in water shapes their minds in ways that diverge from ours. They do not build fire, carve stone, or bend metal. Their intelligence expresses itself socially and acoustically rather than materially. If given time to evolve further, they might construct entire worlds of thought out of sound and memory, architectures that exist in the mind rather than in the landscape. Thinking about these possibilities forces us to confront a limitation in ourselves. We often equate intelligence with technology, with visible signs of progress, tools, buildings, machines. But that is our bias. Intelligence is not always about what is built outside the body. It can be about what is built inside the mind. Whales may already carry sagas within their songs, oral histories longer than any written record passed down through generations. Their intelligence may be no less than ours, only different in expression. Future minds might follow this path. Perhaps they will not build cities or satellites. Perhaps they will build intricate systems of culture, memory, and communication invisible to us. Perhaps intelligence does not always leave skyscrapers. Perhaps it leaves traditions and social structures instead. There is also the possibility of collective minds. Ants and bees already show how colonies function as superorganisms, each individual a part of a greater whole. Decision-making emerges not from one leader, but from the interactions of thousands. What if, in the distant future, intelligence rises not in individuals but in groups? What if thought itself belongs to the colony, not the unit? Such a mind might experience the world in a way we cannot fathom, not as I, but always as we. Plants too suggest strange possibilities. They communicate through chemical signals, share resources through root networks, and respond to their environments in subtle ways. While not conscious in any human sense, the foundations of distributed communication and long-term adaptation are present. If evolution found ways to enhance these processes, a future mind might not move or speak at all, but think in the slow rhythms of growth, decay, and exchange. Such a being might measure time not in seconds but in seasons, not in days but in centuries. And then there is the possibility that minds could be shaped by environments radically unlike our own. If life thrives underground after humanity, intelligence might evolve in darkness, guided not by sight, but by touch, vibration, or chemical gradients. Thought in such a being might be spatial in ways we cannot imagine, mapping the world not by vision but by pressure and proximity. If life adapts to the deep ocean, minds might be shaped by constant pressure, absence of light, and reliance on senses we barely understand. The important point is that there is no single path for thought. Our version is one outcome, not the outcome. Other kinds of minds might think differently, feel differently, even experience reality itself differently. They might not have language in our sense, or they might have it in forms beyond us. They might not value individuality, or they might see it as essential. They might see time as linear, cyclical, or irrelevant. This should remind us how narrow our own perspective is. We're so used to our minds that we assume they are the measure. But imagine explaining human thought to a future intelligence unlike us. Imagine trying to describe how we translate sound into symbols, symbols into speech, speech into culture. To them it might seem as alien as their thought seems to us. What this reveals is that the question of future minds is less about whether they will exist, and more about how utterly different they will be. Evolution does not repeat itself exactly. It explores new solutions each time. If intelligence appear again, it will likely be something we could never have predicted, shaped by bodies, senses, and environments that are not ours. And this opens another reflection. Perhaps there are already minds on Earth we fail to recognize, because they do not look like ours. Perhaps whales already carry epics we cannot hear in full. Perhaps forests already hold communication we dismiss. Perhaps we are surrounded by other kinds of thinking, but our bias blinds us. If that is true, then the future does not need to invent new minds. It only needs to allow them to unfold. In the end, when we ask what future life might think like, we are really asking how flexible intelligence can be. The answer, suggested by the variety of cognition we already see, is far more flexible than we assume. Whether it comes from feathers, tentacles, fins, or roots, thought is not bound to one form. Other kinds of minds may one day fill the silence we leave behind, and they may look at the traces of us the way we look at fossils, wondering what kind of beings once walked here, and whether their thoughts were anything like their own. When we measure time, we measure it through ourselves. Minutes tick by on clocks, years accumulate in birthdays, centuries unfold in history books. We think of time as something that moves with us, because our lives are the reference point we know best. But Earth does not move on our timescale. Its story is written not in hours or years, but in layers of stone, in cycles of ocean, in patterns of sky. To understand the planet's true timescale, we have to set ourselves aside and listen to the rhythms that were here long before us and will continue long after we're gone. Stone carries the deepest record. Mountains rise and crumble over spans so vast that even the oldest civilizations saw only fragments of their motion. Tectonic plates drift across the planet's surface, colliding and separating in dances that take tens of millions of years. Continents that seem fixed to us are in fact restless, their slow movement shaping oceans, climates, and ecosystems in ways no single species controls. A cliff face or canyon wall is not just rock, it is a library of time, each layer a page recording volcanic eruptions, ancient seas, forests that turned to coal, deserts that shifted and vanished. Oceans write time differently, in currents that loop across the globe, redistributing heat and shaping weather. The thermohaline circulation, often called the global conveyor belt, takes about 1,000 years to complete a single cycle. Deep waters sink, surface waters rise, nutrients circulate, and life follows these rhythms. Coral reefs, seagrass meadows, and fisheries depend on patterns that seem invisible to us because they move too slowly or too broadly for daily awareness. Yet these cycles are as real and enduring as the tides. The sky too moves on scales beyond our lifespans. The precession of the Earth's axis takes about 26,000 years to complete a full wobble, shifting the stars we see as north or south. The tilt of the planet changes over tens of thousands of years, driving ice ages and warm periods. Even the orbit itself fluctuates slightly, altering how much sunlight reaches different regions. To us, the night sky looks constant, a familiar ceiling. To the Earth, it is a shifting stage where stars move, constellations reconfigure, and galaxies drift. Measured against these scales, human time feels like a flicker. Our recorded history stretches back only a few thousand years, the blink of an eye in geological terms. Even the entire span of our species, 200,000 or 300,000 years, is brief compared to the cycles of stone, ocean, and sky. When we build cities, when we write books, when we record music, we imagine permanence, but on the planet's timescale, we are temporary marks washed away almost as soon as they're made. This does not diminish us, but it does place us. We are part of a story much larger than ourselves, a story that has been unfolding for billions of years and will continue for billions more. The mountains we climb, the seas we sail, the stars we map. They are not backdrops for our lives, but characters with their own arcs, moving to rhythms too slow for us to follow fully. Understanding Earth's timescale also shifts how we think about our impact. When we speak of climate change, for example, we often talk about decades or centuries. But the carbon we release now will shape the atmosphere for thousands of years. The species we drive to extinction will be absent for millions. The scars of mining and construction will persist in stone long after our languages vanish. In the scale of our own lives, these impacts feel vast. In the scale of the planet, they are just another layer added to the record, another chapter that will one day be buried and rewritten. Stone, ocean, and sky remind us that change is constant. Mountains rise, but they also erode. Oceans circulate, but they also shift with temperature and salinity. Stars move across the heavens, but they also fade and die. Permanence is an illusion, even at planetary scales. The only constant is motion, reshaping the Earth endlessly. This perspective can be unsettling, because it shows how small we are, how little control we truly have. But it can also be grounding. It reminds us that we are not separate from these cycles, but embedded within them. Our bodies are made of minerals born in stars, water that has circulated through oceans for billions of years, air that has been breathed by countless beings before us. We are participants in the timescale of Earth, even if we usually don't notice it. Thinking in this way also opens the possibility that intelligence itself, our brief experiment of thought, is part of the planet's timescale. We imagine our minds as something unique, fleeting, unanchored. But perhaps they too are part of the cycles, rising and falling like seas, emerging and fading like mountains, drifting like stars. If intelligence ends with us, it will still be another layer in the record, another brief rhythm in a larger song. If it returns in some other form, it will simply be another variation of the same process. The Earth trying new drafts across time. To see stone, ocean, and sky as timescales is to accept patience. The Earth is not in a hurry. It has carried on for billions of years and will carry on for billions more. Our urgency is not its urgency. Our endings are not its endings. And that patience reshapes how we might think about ourselves. We're here, briefly, aware enough to glimpse these vast processes, even if we cannot live long enough to watch them fully. We can measure plate movements, trace currents, chart stars, and in doing so, glimpse the immensity of the story we're part of. Perhaps that is one of the rare gifts of our intelligence, not to master the timescales, but to notice them at all. When we pull back from the Earth and think about the universe, the scale changes so dramatically that it can be difficult to hold in mind. The mountains that seemed eternal, the oceans that seemed boundless, the sky that seemed endless, all become small pieces in a larger frame. Galaxies stretch for hundreds of thousands of light years. Clusters of galaxies drift across cosmic webs that span billions of light years. In that context, our planet is a speck, and our species is a moment. The universe does not hurry, and it does not pause. Stars ignite, burn for millions or billions of years, and fade. Galaxies collide, merge, and reshape themselves. Black holes swallow matter and light. These processes are vast and impersonal, unfolding whether we are here to witness them or not. To imagine that the universe watches us is more metaphor than truth. It does not notice. It does not care. And yet, placing ourselves against that backdrop changes how we see our place. For most of human history, the sky was both mystery and map. People looked upward and saw stories in constellations, guides for navigation, calendars for planting and harvest. The stars were woven into culture, into religion, into identity. We felt ourselves part of a cosmos that spoke to us through its patterns. Only recently have we learned just how large that cosmos really is and how indifferent it seems to our stories. The Earth orbits an ordinary star, one among hundreds of billions in the Milky Way. The Milky Way itself is one among trillions of galaxies. There is no centre, no privileged vantage point, no special stage where our lives unfold. To the universe, We are not the climax of a story, but one experiment among countless others. And yet, within that indifference lies a paradox. Because while the universe does not watch us, we watch it. We turn telescopes to the sky. We measure cosmic radiation. We chart the expansion of space itself. We send probes beyond our solar system carrying fragments of our culture in case someone, somewhere, might notice. The universe may not pay attention to us, but through us it has, for the first time we know of, become self-aware. This awareness is fragile. If humanity disappears, the cosmos will continue without memory of us. The stars will burn, the galaxies will spin, the expansion will go on. But while we are here, we carry a rare perspective. We know that we exist on a small planet circling a modest star in a vast dark sea. We know that our lives are temporary, but we also know that our thoughts allow us to see beyond them. Placing ourselves in cosmic context can feel humbling, even diminishing. What is a city, a civilization, a species, against billions of light years? But it can also feel empowering, because even if the universe does not watch, we have the capacity to notice, to wonder, to reflect. We are part of the universe looking at itself, part of the cosmos turning its gaze inward. It also reframes the question of importance. Importance is not something handed down from the stars. It is something we create. We decide what matters in our brief time here. The universe does not need us, but we can choose to value connection, meaning, and curiosity. Our place in cosmic context is not about being central, but about being aware. Awareness may itself be one of the universe's rarest phenomena. Matter organizes into stars. Stars forge elements. Elements assemble into planets. And on at least one planet those elements have arranged into beings who wonder. It may have happened elsewhere, perhaps many times, perhaps never again. We cannot know yet. But the fact that it happened here at all is remarkable. So while the universe may not watch us, we can watch it, and in doing so we weave ourselves into its story. Our time may be short, our scale small, but awareness gives us a kind of place that stone, ocean, and sky alone do not grant. In cosmic terms, we are fleeting. In human terms, we are meaningful. Holding both truths at once is the challenge of seeing ourselves clearly. When we think about impermanence, it often feels like loss. We see ruins of past civilizations and think of decline. We watch forests cleared or species vanish and think of tragedy. We look at the short span of our own lives and feel the weight of endings. Permanence is something we long for, even though nothing in nature has ever been truly permanent. But if we step back, if we look at impermanence not as failure but as part of the pattern, it begins to take on a different shape. Endings belong in stories, and impermanence gives stories their meaning. Look at a leaf. It grows from a bud in spring, spreads wide in summer, catches light, and finally turns colour and falls. The falling is not failure. It is part of the cycle that makes the tree possible. Without impermanence, there would be no renewal, no room for the new. The same is true on larger scales. Species rise and vanish, making space for others. Continents drift and collide, creating mountains that will one day erode. Stars burn and die, scattering the elements that become planets and life. The universe itself moves toward transformations we cannot stop. Our discomfort comes from the way we measure time. For us, endings feel abrupt because our lifespans are short. But from the planet's perspective, or the universe's, endings are just transitions. The dinosaurs did not end life. Their extinction opened space for mammals to flourish. Ice ages did not end the planet. They reshaped its ecosystems. Endings are woven into beginnings so tightly that they are not truly separate. For human civilizations, impermanence has been the rule, not the exception. The walls of Troy fell, the libraries of Alexandria burned, the statues of Easter Island weathered under the sun. Yet each ending gave rise to new cultures, new knowledge, new stories. Rome's fall did not erase its influence. Egypt's decline did not erase its monuments. Even collapse leaves seeds that grow in unexpected ways. Impermanence does not mean erasure, it means transformation. At the personal scale, impermanence is what makes life vivid. Knowing that our time is limited gives urgency to choices, to relationships, to creativity. If we lived forever, would we treasure a sunrise, a song, a conversation? It is precisely because things end that they matter. Endings press us to notice, to value, to remember. This does not make endings easy. Grief is real, loss is heavy. But grief itself is proof of meaning. We do not grieve what we do not value. And if impermanence brings grief, it also brings depth. It reminds us that even small moments are part of a larger story. In a way, impermanence offers comfort because it levels all things. No empire is eternal, no monument immune to erosion, no star everlasting. This truth, while humbling, is also freeing. We're not failing by being temporary. We're participating in the same pattern that governs everything. To wish for permanence is to wish against the very structure of reality. To accept impermanence is to align ourselves with it. When we recognize this, our relationship to endings changes. We stop seeing them as breaks and start seeing them as continuations. The end of a season is the start of another. The end of one species makes room for another's rise. The end of a life feeds soil that nourishes new growth. Nothing disappears into nothing. It only shifts form. This understanding can reshape how we think about humanity's future too. If our species is temporary, as every species has been, then our eventual ending is not catastrophe but continuity. It may feel catastrophic to us, but to the planet, it will simply be another turn of the page. Life will go on, new forms will appear, new experiments will unfold. Even if we fear our absence, the story will not stop. And in this sense, impermanence holds a kind of mercy. It means that mistakes are not forever. Damage heals, though it takes time. Wounds close, though scars remain. The planet itself has endured meteor strikes, mass extinctions, volcanic winters, and yet it continues. No ending has ever been final. Even the death of stars plants the seeds of new solar systems. Impermanence ensures that nothing is truly locked in place, that there is always room for renewal. Perhaps that is why we tell stories with beginnings, middles, and endings. Without impermanence, a story would be endless, unchanging, without tension or meaning. We need endings to give shape. We need them to frame the arc of what came before. The same is true for existence itself. Impermanence is not the enemy of meaning. It is its foundation. When we place ourselves back into the cosmic context, this truth becomes even clearer. Galaxies evolve, stars are born and die, planets form and fade. On those scales, our lives are moments. But within those moments, meaning is possible precisely because they are finite. We are sparks against the darkness, and sparks matter because they cannot last. Accepting impermanence also gives us perspective. It tells us not to cling too tightly, but also not to despair. Our lives, our species, our civilizations will all end. But in those endings there will always be continuations we cannot see. The story is larger than us, and endings are part of its rhythm. So when we think about impermanence, we can let it comfort us. Not because it erases loss, but because it makes loss part of a larger pattern. Not because it diminishes our efforts, but because it shows them to be part of a vast, interconnected flow. Permanence was never the promise. Change was. And change carries endings with it. Not as failures, but as necessary turns in the story. For much of our history, humans have told ourselves that we are the pinnacle of life on Earth. We point to our cities, our languages, our machines, our art. We look at the way we have reshaped landscapes, domesticated animals, unlocked the atom, and touch the stars, and we call it progress. We imagine ourselves at the top of a ladder, with all of evolution climbing toward us as if we were the goal all along. But when we look more closely at the story of life, the ladder becomes something else entirely. It is not a straight climb upward, but a branching web, an endless unfolding of possibilities. And in that web, what if we are not the pinnacle at all, but simply a bridge, a temporary link between what came before and what comes after? The idea of being a pinnacle is seductive because it flatters us. It suggests permanence, finality, completion. But evolution does not work toward completion. It works by experimenting, by testing variations, by discarding what does not fit and carrying forward what does. Dinosaurs once dominated the Earth for over 100 million years, far longer than humans have existed, yet their reign was not a pinnacle. Trilobites filled the seas for nearly 300 million years, yet they too vanished. If longevity or dominance were proof of being the final goal, then we would have to admit that beetles or sharks deserve the crown more than we do. Seeing ourselves as a bridge instead changes the frame. It acknowledges that our intelligence, our tools, our cultures are remarkable, but also that they may not be the end of the story. Perhaps we are a stage in life's long experiment with consciousness, a transition toward other forms of awareness that will come after us. Perhaps we are not the top of the ladder but a temporary crossing, enabling life to explore a new direction. This idea can feel uncomfortable. If we are not the pinnacle, then what is all of this effort for? Why build? Why create? Why strive? But that discomfort comes from our habit of measuring value by finality. If the goal is to be the end point, then being a bridge feels like failure. But if the goal is participation, then being a bridge is no less meaningful than being a destination. Think about the countless species that preceded us. Photosynthetic microbes filled the atmosphere with oxygen, paving the way for complex life. Plants colonized land, creating the ecosystems that animals could enter. Small mammals survived the extinction of dinosaurs, opening the possibility for us to evolve. None of these forms of life were pinnacles. They were stages, and yet without them, we would not exist. Their contributions were bridges, and those bridges mattered. Perhaps we too are playing that role. Our intelligence may create conditions that allow new forms of life to emerge, even if we do not intend it. Our alterations to the planet may drive evolution in directions we cannot foresee. The very technologies we build may one day evolve into forms of intelligence beyond us, whether biological, synthetic, or something in between. In this sense, we may be midwives to futures that will not include us, but that will carry traces of our influence. It is also worth asking whether the concept of pinnacle makes sense at all. It assumes that life has a goal, a direction, an end point. But life is not a story with a final page. It is an open process, endlessly adapting. The moment we declare a pinnacle, the story moves on. Declaring ourselves the endpoint may be more about comfort than about truth. If we are a bridge, then our value is not in being permanent but in being connective. We link the past to the future. We hold within us the deep history of life, encoded in our cells, and we project forward possibilities that will outlast us. Our art, our science, our technologies, our mistakes all become part of the groundwork for whatever comes next. This view also changes how we think about responsibility. If we are the pinnacle, we might imagine ourselves entitled to use the planet however we wish. If we are a bridge, we might see ourselves instead as caretakers of a passage. The way we live shapes the possibilities of what comes after. Our actions do not only affect us, but ripple forward into the lives that will inherit the Earth. Bridges are not glamorous, but they are essential. They make crossings possible. They are temporary by design, but they connect places that would otherwise be isolated. To see ourselves in this way is to embrace humility, but also significance of another kind. We matter not because we are the final word, but because we are part of the sentence that continues. And when we think of ourselves as a bridge, impermanence becomes less threatening. Of course we will end. Of course, our species will vanish, as all species do. But in ending, we will have carried something across just as countless others carried across to us. Meaning does not come from being eternal. It comes from being part of the flow. So are we a bridge, not a pinnacle? The evidence of history suggests that we are. Every dominant species before us thought, if it could think, that its reign was secure. None were permanent. We will not be either. But bridges do not need to be permanent to matter. They need only to connect. And in that sense, our place in Earth's story may be less about being the culmination and more about being the passage, less about being the top of the ladder and more about being one of its many rungs. To accept this is not to diminish ourselves, but to see ourselves clearly. We are extraordinary, yes, but extraordinary does not mean final. Extraordinary can mean transitional. And that too is enough. Thank you for staying here with me through this long journey. If you've made it this far, you already know where the story has been leading. We began with the thought that maybe humans are not the pinnacle of life on this planet, not the final chapter, but something temporary, a phase in a story that has been unfolding for billions of years. And now, as we bring this reflection together, I want to leave you not with answers, but with perspective. When you step back far enough, humanity looks both small and extraordinary at the same time. Small, because our history is brief compared to the age of mountains and oceans, brief compared to the orbit of stars, brief compared to the deep time of the universe. Extraordinary, because in that brief time we became aware enough to notice all of it, to ask questions, to imagine, to tell stories about where we came from and where we might be going. That's what makes us unique, not permanence, but awareness. We know we are temporary, even if we struggle against that truth. We know that species before us rose and fell, that civilizations have crumbled, that our own future is not guaranteed. And still, here we are gathering around words, thinking together about what it means. That act itself is a kind of beauty. We often imagine that meaning comes from lasting forever. We look at monuments, books, songs, and hope they will outlive us. We build, we archive, we try to preserve. We try, but permanence was never promised, and permanence was never required for meaning. A sunset does not need to last forever to be beautiful. A friendship does not need to be eternal to matter. A life does not need to avoid its ending to have value. Impermanence and beauty are not opposites, they are partners. When we apply that same thought to humanity, the picture shifts. Yes, we will end, as every species ends. But the fact that we existed at all, that we thought, that we created, that we left traces in stone and story, is remarkable. We do not need to be forever to be significant. We need only to be. And maybe that is the real gift of seeing ourselves as a temporary chapter. It frees us from the pressure of being the pinnacle, from the illusion that everything was leading to us. Instead, it places us in the flow, part of the same stream as trilobites and ammonites, as dinosaurs and birds, as trees and fungi, as microbes and mountains. Part of a story too vast for any one species to own. But that does not make our page in the story meaningless. Think of how many billions of years it took for the planet to produce creatures who could reflect at all. Think of how rare it may be for the universe to look at itself through eyes like ours. Maybe there are others, maybe there are none. But the fact that we are here, now, noticing, is enough to make this chapter luminous. When the story moves on, as it must, there will be other forms of life, other experiments, other drafts. Maybe some will be intelligent in ways we cannot imagine, maybe not. But our part will always have been written. We were here, we thought, we wondered. We left behind signs in stone and orbit and code. We shaped the earth, for better and for worse. We were not the first and we will not be the last, but we were real, and that reality is its own beauty. The comfort in all of this is knowing that endings do not erase. They transform. Just as forests grow after fires, just as stars scatter elements after they collapse. Just as rivers carve new paths when they overflow, endings are passages. Humanity will one day be a memory in the Earth's strata, a layer of carbon, plastic and fossil. But memory is still presence, and presence is still meaning. So if you take anything from this reflection, let it be this. Being temporary does not mean being unimportant. Our chapter may be brief, but it is part of a timeless story. Beauty does not depend on permanence. Beauty depends on presence, and presence we have. And as you listen to this now, wherever you are participating in that presence. You are part of the moment when the universe is aware of itself through us. That is not small, that is extraordinary. Thank you for spending this time here, for reflecting with me, for holding these questions in your own thoughts. If you found comfort in this journey, I invite you to carry it with you, to notice the ways impermanence can bring meaning, to see yourself as part of something vast and ongoing. And if you'd like to spend more time in these kinds of reflections, you're always welcome back. We'll keep exploring gently, piece by piece, the strange and beautiful story of Earth and life. Because even though our chapter is temporary, the act of wondering about it makes it timelessly beautiful.